Welcome class 9 of Innovera School for your science class. So in our last video we had studied about the separation of the various gases in fractional distillation. We had seen what is the process of crystallization. We had seen the example of obtaining copper sulfate, pure copper sulfate from impure sample. And we had also seen the purification of water system. Okay, in the water work, I had explained you about the sedimentation tank, loading tank, filtration tank and chlorination. Different steps. Okay, so I hope you are clear with this idea. So today what we are going to discuss? Today we are going to discuss the very easy topic, that is physical and chemical changes. In your previous classes you have already studied about the physical and chemical changes. Okay, but in standard 9 let us see what they want to tell us. So to understand the difference between pure substance and a mixture, initially we should know what is the difference between physical and chemical change. Okay, before starting with the discussion, let me clear that physical change is nothing but the outer appearance. Okay, it is changing the outer appearance of the substance, whereas chemical change, it is changing the chemical component present in the substance. Okay, so now let's see. In the previous chapter we had learned few physical properties of matter. Right, the properties we have observed were color, hardness, rigidity, fluidity, density, melting point and boiling point. Yes, these were the different physical properties. And we had also seen that there was interconversion of states. Yes, solid state got converted into liquid. Liquid state got converted into gas. Okay, and vice versa. Okay, so this interconversion of states is a physical change because these changes occur without change in composition and no change in chemical nature of the substance. So in this process of interconversion, you will find that amount of substance will never change. Okay, and the chemical nature of the substance will also never change. Although ice, water and water vapor will all look different. Okay, and they will display different physical properties, but they all are chemically same. Okay, now for example, if you have taken in solid state, if you have taken ice, okay, what is ice made up of? Water. What is formula of water? H2O. Okay, when this ice will get converted into water, it will remain the same H2O. When it will get converted into gaseous, it will still remain H2O. Okay, so the chemical property is same. Now let's see the next. Both water and cooking oil are liquid, but their chemical characteristics are different. Yes, water and cooking oil, they both of them are in liquid state, but they have different chemical characteristics. They differ in odor and inflammability. Okay, what do they differ in? Odor and inflammability. That means they both burn at different temperatures. Okay, some need less energy, whereas the another one needs more energy. We know that oil burns in air, whereas water extinguishes fire. So both of them are doing two separate jobs. Okay, now why it is so? Because of the chemical property. So chemical property of oil that makes us different from water. So what is the different chemical property of the oil? It will be always different from the water. Okay, clear till here? So burning is a chemical change. Why do you think burning is a chemical change? Because during this process, one substance reacts with another to undergo a chemical composition. Okay, in grade 8 also you have studied that whenever you burn a metal, it will form its oxide. That means it is reacting with oxygen and it is giving the different product. Okay, so a chemical change is also called a chemical reaction, because here there is not only the change that is taking place, but there is also reaction that is taking place. Okay, for example, when magnesium burns with oxygen, it will give magnesium oxide. Am I right? So in this way, we understand that a chemical change is also called a chemical reaction. Okay? So now, during burning of a candle, both physical and chemical change take place. Can you distinguish this? Yes? Can we distinguish? The candle, solid wax, it gets converted into liquid wax. Along with that, can you see it reacting with oxygen also? When we are burning, it is of course reacting with the oxygen that is present. Okay, so in this way we will find both physical and chemical, both type of changes taking place. Okay, so here they have asked us to classify the following as chemical or physical changes. So I want you all to find it out so that we will discuss it in our tomorrow's Facebook live class. Okay, they have given you various examples. Just think and categorize them into physical change and chemical change. Okay, this is the task that is given to you. Okay, now let's move to the next point. Now what is the next point? What are the types of pure substances? Okay, now we are going to discuss what are the different types of pure substances. So how you can make out that this particular substance is pure? Okay, on the basis of their chemical composition, substances can be classified as elements or compounds. Okay, so here understanding elements and compound is important and differentiating between them is equally important. Okay, so pay attention to the concept of element and compound. So Robert Boyle was the first scientist who used the term element in the year 1661. Okay, whereas Anton Laurent, he was a French chemist and was the first to establish an experimentally useful definition of an element. Okay, so how did he define element? He defined an element as basic form of matter that cannot be broken down into simple substance. Okay, so he defined element as the matter which cannot be broken down into simple substance. That means it is in the pure form. You cannot convert it further into simpler form. Okay, that is known as element. So elements are again further classified into metals, non-metals and metalloid. Okay, so what is elements further classified into? Metals, non-metals and metalloids. Okay, so now what are the properties of metals? You have already studied it in grade 8. Yes, they have luster. That means they have shiny surface. They have silvery gray or golden yellow color. So color is also mentioned. They conduct heat and electricity. They are ductile. They are malleable. And they are sonorous. Okay. Now examples are metals such as gold, silver, copper, iron, sodium, potassium. Mercury is the only metal that is in liquid state at room temperature. Okay, and non-metals show the properties exactly opposite to metals. Okay, they display variety of colors. They are poor conductors of heat electricity. They are non-lustrous, sonorous or malleable. Okay, so examples are hydrogen, oxygen, iodine, carbon. Okay, coal and coke are the form of carbons. So intermediate properties between these metals and non-metals, they are called as metalloids. So they show characteristic of both metal as well as non-metal. So clear with this? Clear till here? So today we are going to stop with this elements, and in our next class we will see remaining part, that is compounds, and the next concept. Okay, so listen to the video carefully, and if you have any doubt, write it and keep it ready. Thank you, children.